Hello and welcome to this video tutorial on Cisco Access Control List. This tutorial is targeted to Cisco CCNA candidates as well as to anyone who are interested in learning more about access lists. My name is Jack Wan. Please note that this tutorial is not a basic 101 class. If you've had some level of understanding how access list works but just don't know when and how to use it, especially having trouble mastering the topics in today's CCNA exam, this tutorial is perfect for you. If you are a network engineer and would like to sharpen your skills of dealing with access list, this tutorial is made for you. This video is mixed with lab practices along with the lecture. I'm going to show you how things work on the real routers in the lab environment. Let's get started with reviewing some access list basics. An access list is evaluated in a sequential order until a condition is met. Once a condition is met, the following statements are not evaluated. If no condition is met, an implicit denying any applies in the end. A lot of people have trouble understanding the denying any rule in the end. An easy way to memorize it is that think about a network device, in this case it's a Cisco router. What is the most secured state? By default, all traffic is denied unless it's specifically allowed. In fact, a brand new Cisco firewall drops all the traffic until you configure it to allow it. My understanding is a network device like Cisco router and firewalls, they tend to be in the most secure way when the router is put in the network. Let's talk about the difference between a standard access list and an extended access list. Think of a standard access list. It's a simplified version of an extended access list, which only evaluates the source IP address. For example, there's an access list number 10 and permit only the host 192.168.1.1. Keep in mind that the IP address here represents the source, not the destination. An extended access list will specify the source IP, destination IP, as well as protocols such as TCP, UDP, and the ping ICMP packet, as well as the port number. For example, in this case, Telnet is port TCP 23, and the web traffic HTTP uses port 80. When I teach this topic, I always ask folks to think about the packet flow in motion. People always ask me where the access list is evaluated. In the real world, packets travel through routers, and the routers make decisions on where to forward them. There are two places the packets may be evaluated. One is the inbound interface, and the other one is the interface where the packet leaves the router. Looking at this example, a packet travels through a router entering the router's Ethernet 1/0 interface, and it leaves the router through the router's interface Ethernet 1/1. I can apply the access list 1 to the incoming interface with this configuration shown on the left, and I can configure a access list to evaluate the outbound traffic with ACL-2. A lot of people have difficulty understanding inbound, this in keyword and out keyword. When in keyword is specified, this AC access group evaluates inbound traffic. If you keep the traffic flow in mind, you will never mess up with inbound or outbound, because this is entering the interface 1/0 and this is leaving. That's why this is outbound, and you will never mistakenly put in here. Now we know where the ACL is applied based on the traffic flow. what exactly the ACL is looking for. Think of an example of someone is sending you a package. On the package, it has the sender's name and address. In this case, it is the source IP and the port number. Most importantly, it has your name and the address as a receiver. In the data network world, that is the destination's IP address and port number. The package contents represent data. An access list will look at the source info and the destination info until a perfect match. If there's no perfect match, the deny any is applied in the end. Remember we covered it in the last slide? A data packet is delivered from source IP with the source port number to a destination IP with destination port number. In this example, I have the source IP as 64.64.12.1 is originated on port number 2034, and the destination is 64.64.25.5 on port 23, so it's a telnet port. In this example, access list 100 is configured to match this packet coming from source IP 64.64.12.1 and going to the destination of 64.64.25.5 on 23. We've covered what an access list is looking for. Once a perfect matching statement is found, what does the ACL do? I know a lot of people, when they talk about access list, they always think about access list is blocking the traffic or permitting a traffic. That is incorrect. The access list do not permit or deny traffic. In other words, the access list does not take actions. Access list is like a filter. It qualifies or disqualifies the traffic flow through it. The evaluated traffic is then sent to set actions. Some actions can be deny or permit traffic when used with access group. Other actions can be shaping the traffic, like quality of service, or redirecting the traffic using policy-based routing. We've done enough talking. Let's get our hands dirty and play with the labs. Before we begin, I'd like you to get familiar with the lab topology and IP assignment. Think about this lab as composed of 4 routers, and each router has its loopback IP address start 64.64.1.1 represents router number 1. Similarly, router 2 has a loopback interface with IP address of 64.64.2.2. Router 5 has 5.5 and router 6 has 6.6. On the interface that connects to each other, they have the third octet represent the combination of the router numbers. For example, the link between router 1 and router 2 has the IP of 64.64.12.1 on router 1 and .2 on router 2. Same way, on the interface of router number 2 facing router number 5 has an IP of 64.64.25.2, and the router 5 has the IP of 64.64.25.5. By making the IP assignment contain the information of router numbers, you do not have to memorize the IPs. As you see the IP address, you know which router it belongs to.